Alright, so this is the screencast for day 3 of intermediate algebra. Alright, so this example, we're putting together everything that we've learned so far. Alright, so we know to use SOHCAHTOA. Alright, we know to label our sides of our triangle, adjacent, hypotenuse, opposite, and now we can actually apply these functions to figure out different things. For instance, we want the height of the building to the nearest whole foot. Okay, so height means this side. We want how tall it is. Alright, so what we have is this angle, which is 76 degrees. We have the 200 foot, and we want the height. So according to this angle right here, we want the opposite side, and we have the adjacent side. Okay, so looking at SOHCAHTOA, opposite, adjacent, we're going to use tangent because that's the one with opposite and adjacent. Right, opposite, let's see, here's where opposite, adjacent, tangent's the only one with both opposite and adjacent sides in its calculation. So if I write out, I have tangent of, what is my angle? 76 degrees equals opposite d over adjacent 200. Okay, so we applied SOHCAHTOA. We're using our trig function to compare the different side length ratios. Now I have to get d by itself. So let's multiply by 200 on both sides. So I see that the distance, the height of the building, is going to be 200 times tangent of 76 degrees. So let's show you how to put this in your calculator. Okay, so we have our calculator pulled up. Right now it says RAD. We must be in degree mode, DEG. So you have to go into your settings and change into degree mode. So then you click doc, settings, document settings, and then you want the angle to be degree, DEG. Alright, so we had 200, and then we're going to be multiplying by, and then you see where it says trig, you click on the trig, go over to where it says tangent, and then we had an angle that was 76 degrees. Push enter and it tells us 802.156. So this is where you find our trig ratios, right here. And you have to make sure, if you're using degrees, it has to be in DEG, which is degree mode. Otherwise your answers will be wrong. Okay, so 802.156, but what's the nearest whole foot? So the nearest whole foot is 802 feet. It's a pretty high building. Alright, let's use again. Use a trig function to find each value of x, round to the nearest tenth if necessary. So you may have done something like this before with geometry. Okay, so I have this angle. This is my adjacent side. This is my opposite side. So looking at SOHCAHTOA, which trig function can I use that has both opposite and adjacent? Tangent. So my angle is 30 degrees. My opposite side is x. My adjacent side is 7. So we're going to plug this in. Right, tangent of theta is opposite over adjacent. Let's plug in tangent of 30 degrees is x over 7. To solve, let's multiply by 7 on both sides. So I can say 7 times tangent of 30 degrees is going to be, it's about 4.04. But we're not nearest tenth, so it's going to be 4.0. Now, alternatively, we could have recognized that this is a 30, 60, 90 triangle. It's a special triangle, 30, 60, 90. So let's draw out 30, 60, 90. Okay. So you know across from 30 is x, the hypotenuse is 2x, and then over here, across from 60 is going to be x root 3. Well, I see I have a 7 and I have an x root 3. So I can set those equal. 7 has to equal x root 3. So if I divide by root 3 on both sides, I have 7 over root 3 is x. If I rationalize it, I have 7 root 3 over 3. And if you put this into your calculator, you get the same answer. Perfect. Let's keep going. Alright, so let's go through and label what we have. I have this angle, I have the hypotenuse, and this is the opposite side. Write out SOHCAHTOA, and let's figure out which one we should use. Alright, so I have the hypotenuse. Here's hypotenuse, hypotenuse. I have the opposite side. things with opposite, things with opposite. Okay, so clearly we should use sine because it has both the thing that we don't know and the thing that we want to know. So if I take sine of 20 degrees, we have opposite x over hypotenuse 32, multiply by 32 on both sides. 32 times sine of 20 degrees is x. If you put this into your calculator, you get 10.9, because we're rounding to the nearest tenth. Because it is technically 10.94. Round to the nearest tenth is 10.9. Alright, let's keep going. So I have this angle right here. Here's my adjacent side. Here is my opposite side. Let's use tangent of theta is opposite over adjacent. How do I know this? We look at SOHCAHTOA. My tangent is opposite over adjacent. So tangent of 49 degrees is going to be opposite 17 over adjacent x. This one's a little harder. Alright, we have to multiply by x on both sides. So I have x times tangent of 49 degrees is equal to 17, and then we must divide by tangent of 49 on both sides. Okay, once we have that, plug into your calculator, you get 14.8. So the hard part is finding which function to use, which trig function, and then actually making sure your calculator is in degree mode. Alright, inverse trig functions. If the inverse trig functions are used to find the measure of an angle, so this is how we find the measure of an angle when the sides are available. So this symbol is the sine inverse. Literally you say sine inverse. So I'm trying to solve for this angle here. What you have to do is take sine inverse, that's sine to the -1, sine inverse of both sides. Take sine inverse of both sides, sine and sine inverse goes away, and you would get x is equal to sine inverse of -1/2. That's the measure of angle x. So note you can't divide by sin. It's like sine, cosine, tangent. These are similar to the division symbol, multiplication symbol, right? You can't just divide by a division symbol. It doesn't really make sense. Alright, find the measure of angles A and B, round to the nearest tenth. So let's find measure angle A first. Here's my adjacent side, here's the hypotenuse, here's the opposite side. I'm going to go ahead, I'm going to use cosine of angle A. Let's see, what should I plug in? Cosine is adjacent over hypotenuse. So 14.4 over 17. So 14.4 over 17, and if I take the inverse, let's see, cosine, yeah. So I'm going to take cosine inverse of both sides. Cosine inverse, cosine inverse. That's the only way I can cancel out that cosine. So A, the angle A, is going to be cosine inverse of 14.4 over 17. So let's go back to the calculator and let's show you where you can do this. Alright, so notice that this is, cosine inverse right here. And we're taking 14.4 over 17. So we get 31.106. So that's going to be, 32.106. We're rounding to the nearest tenth. So it's going to be I feel like I put that in 14.4 over 17. 14.4. Okay, yeah, we're good. Okay, this is 32.1. We want to the nearest tenth, so okay, 32.1 degrees. So this is the angle, 32.1 degree. Now, we could do sine of this. No, we want to find the other angle. Okay, so now I want to do angle B. I want to know this angle. So here's my adjacent, still is hypotenuse, but now this is my opposite side. So I'll take cosine of cosine of angle B is going to be adjacent 9 over hypotenuse 17. So if I take cosine inverse of both sides, B is going to be cosine inverse of 9/17. So this is going to be, let's go back to our calculator, cosine inverse of 9 over 17. So 58.0. There's a little bit of a rounding thing. That's because the side lengths weren't like perfect Pythagorean. There's some rounding errors on that. 58 point. So this is 58 degrees. If you add these together, they should be equal to 90, but this is 90.1. It's because if you take Pythagorean theorem of those three numbers, it's not perfect. Alright, find the measure indicated angle, round to nearest tenth. So here, according to this angle, I have the hypotenuse and I have the adjacent side. So cosine of x is going to be adjacent over hypotenuse, right? Let's write out the SOHCAHTOA. So cosine is adjacent, 15 over hypotenuse, 17. We just take cosine inverse. We will get 28.07. We want to the nearest tenth, so this is going to be 28.1 degrees. Alright, let's list out again. I have adjacent, opposite. Interesting. Alright, looking at SOHCAHTOA, seems like I will have to use tangent because that's what has both the opposite and adjacent as part of it. So tangent of x degrees is going to equal, it's the opposite over adjacent, 27 over 18. Okay, so if I tan inverse both sides, my angle x degrees is going to be tan inverse of 27 over 18. Alright, and you find tan inverse the same place you found the other ones. Tan inverse of 27 over 18. So this is 56.309, so this is going to be 56.3. So we want the nearest tenth. 56.3 degrees. Alright, we're getting close to the end. Maybe use trig functions to find the values of x and y, round to nearest tenth. Okay, so we want both x and y. I'm going to use this angle. Here's my hypotenuse, adjacent, opposite. Okay, so let's go and let's solve for hypotenuse first. So I have adjacent and hypotenuse. We're going to be using SOHCAHTOA. Seems like I should use cosine if I want adjacent and hypotenuse. Cosine of 41 degrees, we're just writing out the ratio. Adjacent 28 over x, multiplied by x on both sides, and divide by cosine of 41. So we see that the hypotenuse is going to be 37.1. If we go over and we want to solve for the missing side length, y, let's see, I have the opposite and the adjacent side. Opposite, adjacent, that calls for tangent. So tangent, 41 degrees, is going to be opposite y over adjacent, 28, multiplied by 28 on both sides. Plug into your handy-dandy calculator and we get 24.3 for my missing y side length. Alright, we're at the nearest tenth, round to the nearest tenth, we're good. Now we're solving for the angles. Let's see, according to y, I have the adjacent and the opposite side. Let's see, let's do the x instead. Adjacent, opposite side. So I can take tangent of x degrees. Why am I using tangent? Because opposite and adjacent, this is the only one with both opposite and adjacent. So 19.2 over 17, we take tan inverse of both sides. Tan inverse of both sides. X is going to be tan inverse of 19.2 over 17. So this is going to be 48.5 degrees. Now there's a little trick, a little shortcut I'm going to do. So we know the total number of degrees in a triangle is 180. This one is 90. And if I subtract 48.5, this is going to give me the missing missing angle measure of y. So that's going to be 41.5 degrees is y. Okay. I'm going to skip this one. Screencast is getting a little long. The solutions are already posted. Let's go and let's solve each equation. So I need to solve this. How do I do it? Well, I need to take cosine inverse of both sides. Alright, when I take cosine inverse, it gets rid of the cosine. Use cosine inverse, sine inverse, tan inverse when you're trying to solve for angles. solving for angles. Alright, so if I put this into my calculator, we get 79.5 degrees. Is this my last page? Oh, it is. I could do that. I'll go back and do that one. Here, I want to take tan inverse of both sides. Now I'm being very specific, right? Writing this out for you because that's the only way that you can cancel out and get to the angle itself. Alright, you can't divide by tan. That's not allowed. So my t is going to be equal to 73 degrees. Alright, if we go back up here, we can go ahead and solve for this one. Little bonus action here. Let's see. Let's work with this x degree. This is my hypotenuse. This is my opposite using SOHCAHTOA. So if I take sine of x degrees, opposite over hypotenuse. I'm just plugging in the opposite number and the hypotenuse. Sine inverse both sides. Right, if I take sine inverse of sine of x, the sine and sine inverse go away. Take sine inverse of 7 over 15.3. So if you plug that into your calculator, you will get 27.2. So these are complementary. I think add to 90, because altogether, all three angles are going to equal 180. So 180 minus 90 means these other two angles have to equal 90. So if I take 90 minus 27.2, we get 62.8 degrees, and that's going to be my y angle. Awesome, so that's it, and this is the last new lesson of the year. Have a great rest of your day.